Okay, everyone. Good morning. My name's Ollie Whitehouse. I'm an associate director with NCC, and we're going to discuss software security austerity. Yes, it's topical because of the current financial climate, but specifically in the concept of security debt in software development. So what we're going to cover is we're going to look at the basically what security debt is, discuss and why we care, how it manifests itself. We'll go through some kind of debt management strategies, and then on to some conclusions. So this is really based on experience that I had in a former life of working with large volumes of code and a very good security team. You start to uncover a large number of vulnerabilities very quickly, and you'll see kind of some of the headaches that causes us. So before I continue, I do apologise. Obviously, we're using the kind of the financial debt metaphor, and it is abused extensively during this presentation. But as you'll see, it does work on multiple levels when we start thinking about the problem. And the other thing to point out is that this presentation is actually based on a paper that was written by myself and a previous colleague, James Vaughan, and we released in March of 2012. So if the concepts interest you and you want more kind of language around it and more detail, then I encourage you to go and read the paper. So what we're going to look at first is what the concept of security debt is in the concept of software. So this builds on a concept or an idea of technical debt. The idea that due to code crunch, getting a product to market or a system live, that you have to kind of rush code a certain degree to get it out the door. And as a result of which, by not having bug-free code, you incur some level of technical debt in the software. And so we can take this concept and extend it to security, specifically, as they say in technial debt, that every time you continue to work on that just not quite right code, you're wasting effort if you're going to have to go and refactor or remove it in the name of features. So when we start looking at security debt specifically, the reality is that there is no software without security bugs, vulnerabilities, whatever you wish to call them. So it is present in every piece of software that we have, and it really comes down to a trade-off between kind of making perfect software and shipping nothing, or fixing only the most kind of critical issues and shipping something, or real world business. And you'll see that some of the themes that we have in this presentation will be primarily around this last point, that there's a lot of, especially in our industry, where we focus on kind of technical traits of vulnerabilities and how much risk that they present in our world, but we don't necessarily have the tools or the language to go to the business and really kind of give them the tools that they need to make the decision on whether or not to ship or not ship if it's going to impact their sales. So the real problem that we get is before you have a secure development lifecycle, or before you're even finding vulnerabilities, you're blissfully unaware of what your problem is. The reality is that as you get better and as kind of secure development lifecycles are deployed, or you are a focus of unwanted attention by external researchers, or you build your own internal capability, the reality is that you get this new problem, which is you find lots of vulnerabilities. There is a natural tendency when you find lots of vulnerabilities to only focus on the most critical and severe. So you do that release after release after release, only focusing on the most critical or severe, and you have this ever-growing mountain of medium and low security issues, which no one in their right mind would focus on, but just kind of keeps growing and keeps growing and keeps growing until some smart individual works out how to chain what you thought were 5 previously medium or low vulnerabilities into the equivalents of a critical vulnerability. So we understand now that we can't just focus on these critical or severe. We have to look at some of these lower issues, and that's really what we come back to, is coming up with strategies to service, rightly so, the most critical or serious issues that we're discovering, while also kind of trying to pay back some of this debt that we've got in this ever-growing mountain. So really, when we start looking at the types that we have what's known and unknown, right? So if you start out today and you've released a product and you don't have a security team, all of your security debt is primarily unknown and latent. You don't know how bad it is, you don't really understand the scale. And so people think, okay, what I'll do is I'll get a bright bunch of security people on board and we'll find all the vulnerabilities, which is wonderful, and then you get a load of known security issues, and now you can be kind of accused of being negligent if you don't solve them or similar. So when we look at the sources of kind of where security debt comes from or where security vulnerabilities come from, there are really kind of three key. So there is the code that my own development team writes, and you would hope over time as they become better trained that will become less. Increasingly, no company has the finance or the business desire to write all of their own software. That's very much a dead model. So we increasingly rely on a supply chain and then dependencies. And so the supply chain is where I buy an off-the-shelf third-party component which I may not have source code access to, which is coming to me in binary form, that I have no visibility of over the kind of the code quality. So the great example here is like Adobe Reader. So Adobe Reader 10 actually has software from 9 different suppliers involved in its production. So there's the code that Adobe writes, but there are 9 other entities producing software and code which goes into that final product. So while Adobe may come out and say, we have a wonderful SDL, we're making all of these strides and these improvements, that can't necessarily be said by all of these kind of piddly little 3 people in a goat software shops that may be supplying components to that product. And then we have dependencies. So this could be, again, COTS I use, but it's typically open source in some form, guise or another, that you'll be using, which you don't have a kind of formal support. So there's an interesting problem where, again, your security team gets better and more able, and they start finding vulnerabilities in open source components. There isn't an incentive in many commercial software companies to necessarily fix those vulnerabilities or those bugs in all cases when they're being meant to be writing new features of the product you were trying to integrate that component into. So as a result of which you have an increasing number of vulns in open source components, but no one to fix them and no kind of financial incentive to do so. So those are kind of really the core 3 sources. And this is an important point around secure development life cycles. So having an SDL doesn't mean any zero debt. It literally means the discovery and then coming up with strategies on how to fix the bugs that you're finding. The reality is that most companies will go through many years of the second to last point here, which is if you've got a very large old code base and you start looking for vulnerabilities, the reality is that if that's been developed for 10 years, that's not going to be bug-free or security bug-free within 2. The likelihood is, as you get better, more familiar with the kind of classes of vulnerabilities that manifest themselves in the product, you're going to have this explosion of vulnerabilities, which makes the product look horrendous, but it's just kind of that discovery process because you're investing resources in an underinvested area previously. And then you get accelerated discovery. I'll discuss specifically how accelerated discovery occurs later on, about now. So why we get accelerated discovery is really born out of these points. So you start engaging earlier in the life cycle, so you start spotting kind of crazy requirements coming down from product managers that say, we should use NFC and we don't want any user interaction, we just want to tap and go. You start using static code analysis more, you start using fuzzing, and then you start having this kind of weird anomaly, which is because there's increased awareness within the development teams themselves, because they've been bashed over the head with the bugs coming in, they start coming to you with kind of fessing up, well, we've discovered this whole kind of tranche of bugs ourselves. So because you're spreading out kind of who is discovering bugs, you get more of it. And then when you get, unfortunately, the situation where issues are reported in, you start doing root cause analysis and then variation hunting across code bases. Again, you kind of get sudden explosions in vulnerabilities being discovered. So what we've discussed is kind of how they manifest themselves. What we're going to go on to now is, why does a company allow a product to ship with vulnerabilities? Well, what's the kind of thinking behind it? And it goes back to one of the earlier points. The reality is you can't fix every security issue, even with the best will in the world, because you'd likely go bust. So the reality is that organizations try and come up with different risk strategies on kind of how to quantify the severity of the vulnerability and whether or not they should fix it, should they stop the release, should it be a hot fix immediately after release, et cetera, et cetera. So, and this goes back to also the earlier point about about speaking to the business. So again, I was very good previously putting on my technical hat, stomping around going, this is a CVSS 10, it's remote route. And they'd go, that's lovely, that really is lovely. But we also have, 20 million worth of marketing dollars ready to go on that day. You're asking us to realistically stop this product for a vulnerability that may never ever see the light of day. So you don't have the ability to come back to that. So the reality is that there are numerous inputs into the discussion that you end up having with the business. What is the cost to us as a business of a security response incident? Does it impact our brand liability? The reality is that I think RSA, I'm going to pick on RSA throughout this talk, I suspect, as they've demonstrated, they can be owned kind of top to tail, have vulnerabilities in their products, but people are still buying RSA, right? No one's suddenly kind of run away from that boat. So I think what we see here is that in cold, hard business sense, people don't really care about security issues. Yes, it creates some headlines. Yes, it creates a bit of an icky feeling, and it creates some bumps along the way. But the reality is as long as you're demonstrating that you're doing something, not necessarily perfect, but you're doing something, you'll be able to continue having security issues. And then there's massive resource considerations, and then kind of the impact of the issue. And then I'll discuss a little bit more of these in some detail. But again, this is providing or being able to answer these questions in a coherent way to be able to create the business case on whether or not that issue should or should not be fixed before ship. So one of the things that is increasingly becoming being thought about is latent debt. So the idea is that we have software that's so complex, ever-changing, that we have vulnerabilities pop up all over the time, or all over the place. We don't have the resources to discover, let alone fix. So how do we deal more resilient software? So the common theme, the other phrase which is used to describe this is rugged software. So the idea is that you build software as much as possible that can handle security issues being present, but not being catastrophic in terms of their impact on the system, i.e. due to low probability of exploitation because of mitigation, because of investment required on behalf of the researcher in order to get them to exploit, so you just slow down the rate of exploitation, etc., etc. So the idea here is trying to build our own software so it can survive a certain level of attack or scrutiny, although we know there are bugs there, but then also trying to drive through our suppliers and through our dependencies a similar mindset. So they are employing the right compiler defenses. They are at least kind of thinking about how to make software fail in a more elegant fashion. So when we start looking at some of the strategies around debt management, there are a number of different approaches, and the earlier ones in this slide deck are more sensible, and the later ones I don't necessarily encourage you to deploy, but they're included for kind of more as a thought exercise. So firstly, why do companies care about software security? And really, these are some of the big drivers. Business, if they were left to their own devices, wouldn't care about software security. It's a pain. It doesn't add features that my clients buy. It costs me resources, it slows down innovation, and it's always a headache when we come to the release review cycle. But these are kind of what is starting to make them sit up and listen. So there is an expectation, depending on client sector, around the security of a product. There are regulatory requirements, be it PCI, which is working perfectly, or similar, around, again, the software, the security of software or systems. The increasing cost of debt I refer to here is basically the response costs. So every time you get an external report of a vulnerability and the researcher says, we're going to drop it tomorrow, and you have to scramble around, have your PR lined up, development teams working overnight to do root cause analysis, turning that patch, full regression cycle. If you're actually taking that approach, that gets quite expensive quite quickly. And so it's kind of the cost of that debt. And again, as attackers get better and as more people start looking at our products, we may want to be seen to be doing something. And the best way I can summarize this, so I did these graphics at a former life, and so I appreciate they're a bit crap circle-like, but you'll get the point. So typically we go through kind of a technology innovation phase. we establish a new market growth, and then we end up with widespread use. So mobile devices, it's been the rage now from security researchers, I guess, for the last 4 years, but mobile devices, smart devices have been around for over a decade. It's just it's reached that saturation point. Not everyone is looking at Windows anymore because people just don't use Windows as their primary computing interface. People are using these diverse systems, and so they're looking at them. When we start applying this type of life cycle to vulnerabilities, we always try and explain to clients that this is the reality. That if you are a new product firm, or you have a new product, you release that product first, your market slowly grows, and then the researchers get access to it. And I think, good examples that we've seen here are GSM, right? GSM has been around for over 2 decades, and there was a barrier of entry to get access to the technology to be able to research it appropriately. So it went through kind of that niche vertical aligned technology, it went through that market growth, and then the researchers got access to the technology, and all hell has let loose as a result of that. And so we get the increasing number of security vulnerabilities, and then kind of governments come around, or kind of the GSM Association comes around, or industry forum groups are created saying we have to do something about this. And so what we always say is, yes, you can get away with not taking your security kind of responsibility early on, but just realize when you hit the yellow piece of pie, that's when you're going to start paying for it. And you better have a plan to quickly redress that balance of all of that underinvestment you've done in software security when you're getting a bloody nose every Wednesday because someone has just popped your latest Java patch. So when we start looking at we're at the stage now where we have, we've employed the best researchers we can, or security assessment teams we can. We've paid millions for fortifying Coverity. We're using Veracode to do static analysis, and we just now have like a balloon of bugs. So we now need to work out that we have 3 people assigned to actually fixing these. How do we prioritize all of those lower issues and come up with strategies of actually getting them fixed in some order? So we basically come up with interest rates, or faux interest rates, which is basically a risk assignment. And it goes back to the earlier point, and as you'll see, the CVSS model is very techie focused and doesn't take a number of real world inputs, because it doesn't, for example, CVSS does not take into account the likelihood of discoverability. So yes, there is some fudge factor you'll see in some of these slides, but they're important questions to ask. A lot of companies employ experts, and they employ experts for a reason, and you want to ask their opinion in these kind of risk decisions rather than taking a very paper 10 versus a 9 versus a 9.2. Yeah, so this is the kind of the retro approach to understanding what a threat is to a system, which I don't think, again, answers all of the information that a business needs. So we have motivation, capability, opportunity, and impact, which is extremely simplistic. We then had Microsoft come out with DREAD, which was damage potential, reproducibility, exploitability, affected users, and discoverability. So again, they started to take into consideration what users are affected here, and that's a key one. So if your users, like anyone that uses Facebook, can't have a reasonable expectation of security, for example. So the reality is that yes, it may affect a lot of users, but what do they expect around security versus we sell, super crypto VPN version 12, well, there is an expectation of security around that product. Or we produce a mail filtering gateway. The fact that malicious mail can pop that mail filtering gateway is probably a little less than ideal. And then we have, again, CVSS, which takes in its base some very minimalistic properties of the vulnerability, and then you can apply temporal or environmental scores. But again, it's a pretty poor measure. So one of the ideas that we wanted to kind of convey really here is this is more, we think, a more evolved model. So again, what is the impact of the vulnerability? What is the distribution of software? So again, having a CVSS 10 bug in a piece of software that 6 people use, that is like the consequence of that is minimal. So you wouldn't focus on that CVSS versus a lower classified bug which is used by a far wider user group. Disclosure status, the likelihood of discovery, again, if it is a kernel bug which only your researchers have found after poring over the code for 6 months, You know, the likelihood of external discovery is going to be a little way out, I think, in the majority of cases. I think you could likely say that. Are there the presence of mitigations? And these are some themes in some other slides I do. So the presence of mitigations is not a solution for sure, but it does give you some breathing space in the majority of cases. And at least having them, you know, allows you to push back reasonably and say, we don't need to fix this tranche of buffer overflows because we have stacked cookies, for example. You know, that is, I think, a reasonable expectation if you want people to focus on logic issues for which there are no mitigations. Complexity of exploitation is self-explanatory. Again, access requirements in terms of to the software or to the system, and then the customer expectation of security. And again, you know, if you're selling into a very security au fait market, financial services or some other regulated industry, then there is a higher expectation than the Facebook generation using Facebook. So how do we start doing repayment? And you'll see that there are a number of themes on the repayment model. So one way is to do new version requirements. And at the new version requirement stage, you wouldn't say, fix this particular bug. Again, this is where you would try and drive in those defenses to either make the software more rugged or harder to exploit, or some other defensive measure that buys you breathing space on other bugs that you may know about or do not know about. You can obviously drive architectural requirements here, and it's a pretty effective way of driving more kind of strategic goals through the software. Severity prioritization, this can work quite effectively, where you've calculated the risk on all of the vulnerabilities and you start assigning them releases, basically, on when you want them paid back, and that's non-negotiable. So you can say, low issues, we are going to solve 10% of our low issues next release +3. And it at least gives the development teams visibility of the expectation from the business, and it allows them to staff up accordingly because they know on the hook that they need to solve 10% of today's low security issues by the next release. Whereas they, you know, all of your serious issues maybe have to fix kind of by next major release and criticals on any release. The percentage reduction model, this, you know, again, this may or may not work for you. So you say 100% have to be fixed by the next release, and then you pare down on percentages. Again, it's giving visibility to the dev teams on what the expectations are to kind of pare down some of these lower. So you'll see, basically, we're trying to service or not ignore moderate or low forever. Having a low bug that's been around for 3 years, you know, why is it open? Do you know, just close it if you're never going to do anything about it, because otherwise, why have you bothered even reporting it? Then we get into the situation of forced repayment, and so this is where effectively, you know, a bug you knew about, someone turns up and they report it or they start exploiting it. And obviously this is the most expensive way of repaying. This is where you enact, you know, engineering teams, PR, and all of those types of activities, and so it's something that we wish to avoid in a majority of cases. Debt expiry is probably one of the more interesting kind of concepts. So this is the idea, and this is what Microsoft is effectively doing now. So they've got lemons in their software portfolio, NT4, older versions of Windows, which they have no desire to backport all of the patches from newer versions of Windows. So what they do is they put them on extended support, and you can have some clients continue to pay to have the patches turned. And then they go simply at that point, well, we're not going to do anything now. We're going to announce it's end of life, and you are literally on your own. So what you're doing at that point is saying, yes, we know about all of these vulnerabilities. We're not going to disclose what they are, but we're going to make it the client's problem if they continue to use arcane software that we're not in the business of supporting. And so that's when we start getting into the realm of using things like EMET and other kind of mitigation techniques to try and band-aid this software so we can keep soldiering on and using it as users, but the vendor that has no interest, you know, in the long term of maintaining that old code base, and rightly so after about a decade. So debt overhang is an interesting concept, and again, it's borrowed from the financial world. So the idea here is that you've had this excellent team, you've got all of these critical security issues, and you've not patched any of them, or you haven't invested any debt, and then you've become Adobe, and everyone is basically firing in vulnerabilities week after week after week after week, and it's getting kind of very expensive, and you're having to focus development teams' effort on fixing those bugs, doing testing just around near-term reported security issues. And by doing that, you basically take those resources that would be otherwise innovating or developing new product and giving you your next idea for your business. They're focusing on servicing very quickly, or in the short term, lots of bugs. And so you slow down basically your business's ability to evolve, innovate, and kind of create a new market. So by having basically poor security investment, you end up, as it says there, it's death by 1,000 cuts. You're putting all of your engineering resources into shoring up, patching, instead of writing the new great features. And then this strategic debt restructuring is another way of saying what Microsoft did with IIS. They said at that point is, IIS 5, absolute pain. The more we dig, the more we find. And it looks like really quite scary to actually try and band-aid all of those patches into that code base. So that's what we'll do, is we'll write that off and we'll actually write a new version from scratch with everything we've learned to date. So kind of taking that whole kind of throw away and start again, not many companies can afford to do that, but it is an interesting concept in of itself. And I don't think anyone but Microsoft would ever, if you imagine you try to rewrite WebKit from the ground up now, that would be pretty much a many-year effort, and I don't think many would take that on. But it's an interesting concept anyway. If the company is in such a dire straits where they just don't want to bother, and they would just say, we're going to live with it, it's going to be a rocky 2 years, but the next new release written from scratch will kind of resolve those issues. And then we have the concept of bankruptcy, and literally the concept of bankruptcy is, again, similar, where you say, I need to bin this and I may exit from a market as a result. So we sometimes see this with security vendors or others where they say, well, we're not selling that product anymore, we're never going to release that product, we're going to withdraw from that market. So they literally just write off the code, make the problem the users, and then forget about it. And again, it's a brave person that does that. So when we were writing the paper originally, this was one of the concepts that came up, and I wouldn't suggest people do it, but it is an interesting idea of the fact that if you try and continually patch vulnerabilities or kind of design systems to be impenetrable, that you will fail in the long term. So instead, design software that can take a level of successful attack, or systems that can take a level of successful attack without kind of everything being compromised. So really planning for the consequence. And I'm not sure anyone would be brave enough to do this, to honestly say we're not going to do kind of code review and fix every memory corruption vulnerability. Instead, we're just basically going to design the software so it's highly compartmentalized. It's the right strategy, some would argue, but I'm not sure anyone would necessarily adopt this model. But it is in itself an interesting idea. So, in conclusion, zero debt of software, so security bug-free software isn't good for business, because the reality is if you've got there, you either have a team that isn't good enough to find them all, or you've invested far too much. The presence of an SDL, again, is almost the start of your problem. It enables the discovery and the kind of resolution of those vulnerabilities, but it doesn't kind of solve the ever-growing mountain again, where discovery gets so good because of automation that the resources to fix aren't available. Again, a pure risk-based approach, so again, focusing on severity of the issue allows this ever-growing body of lower-class vulnerabilities to increase and grow over time without ever being serviced, which, as we have seen, increasingly people are chaining vulnerabilities like several low or mediums, and that can turn into a serious or a critical, kind of that aggregate scoring, which isn't captured when you rate a vulnerability in isolation. Outsourcing, again, may allow products to come to market quicker or reduce your investment in software development, but basically all you're doing is also outsourcing the responsibility to discover those vulnerabilities and fix them. So the most mature model, as it says there, is really to kind of understand with the SDL, but then come up with some types of payment strategies around how to service everything that you discover in the most economical way based on not just its technical criticality or severity, but other kind of factors that you would need to take into as part of the business. So I think we're there, so we can get to lunch now, but are there any questions or statements? No? Good. Well, yeah, one question. Thank you. Yep.
Hi. You haven't mentioned anything about incentives in this, and I'm kind of thinking that actually when it comes to security economics, incentives are a big part of it. Any comment to make on how incentives work in this?
So the only incentive businesses have at the moment is if they lose market, if they can attribute loss of market share or clients to a security vulnerability, or there is a regulatory penalty because of some kind of demonstrable negligence. And at the moment, I don't think any business is can accurately attribute at least a kind of loss of market share or clients to a particular security vulnerability. Obviously, Microsoft thought that they were on the risk of doing it, which is why the memo came out when, and that was 12 years ago now. But I don't think since then, like Adobe, people still use PDF Reader and Adobe Reader, right? Java, people are still using Java because it's critical to their business. So I don't think there are enough incentives yet, and I think that's why businesses are being a little bit kind of haphazard and risk loving, I guess is the phrase. In terms of incentivizing developers, that's a different problem to write secure software, because even with an SDL, you can have developers that really don't care. And so one of the ideas which I personally like is kind of like the gamification. So you almost have like Xbox style achievements being unlocked if developers write code that gets through static analysis, fuzzing, code review, etc. And no bugs are being found. They're a level 6 mage in writing secure software or something. But they kind of like that idea because it's another badge to collect. So different ways of incentivizing different people, I guess. Any other questions? Okay, well, thank you very much. Enjoy your lunch.